The integral, what is work? Negative is this negative. And what is work? The integral of the force. What is the integral of the force? The integral of the conservative force times what? Times the displacement delta x or dr in any dimension. Scalar product. This is very important definition. Delta u is equal negative the integral of the conservative force dr. But if I use the external force, will be positive, because the external force and the gravity always will be in opposite direction. So this is delta u. This is very important definition, which I will include here. What is potential energy? Delta u is equal negative the force done by conservative force, dr, scalar product. And that's the general definition of potential energy. But if we have the potential energy associated with x or with r, how can we find? So if instead of the force, we don't want, if we don't have the force and while we have the potential energy, how can we solve for this situation when I want to find the force? What do I do? In one dimension, in three dimensions, we have to use a big gradient. But here, if I derive this formula, delta u equal negative the force dr, if I find the derivative in both sides, the derivative of delta is the same thing, pretty much. Delta u equal, if I find the derivative in both sides, the derivative of this delta will be du, the derivative. On the other side, what I get? What is the derivative of this? Will be just f. So will be negative f c over what? With respect to what I am deriving. With respect to r. So this will be in one dimension. In other words, if I want to get the conservative force, will be negative du over dr. So the conservative force will be equal to negative the derivative of du over dr in one dimension. In three dimension or two dimension, fc, we have to use the term gradient. If you are doing multivariable calculus, you should be familiar with the term gradient, which is negative delta, but upside down, not delta. This. And this, I will say d, or the gradient, u, du. So this the gradient converts from a scalar to a vector. That's the definition of gradient. What is gradient in math, which we will use it here in class? It's just an introduction because you can use it in further courses of physics. This symbol is the partial derivative with respect to x, I. For this reason, this converts from a scalar into a vector, because this is the definition. So will be, in other words, this gradient of u will be du over dx. So you will derive partially the u with respect to x plus the derivative or partial derivative with respect to y, j, plus the partial derivative with respect to z, k. As you can see, this is not the normal symbol of derivative, right? What is the normal symbol of derivative? A normal d. This is not a normal d. This means partial derivative. How many of you are in multivariable calculus? So this conversation is then, for the future. In this class, will be just the derivative. Got it? Because will be one dimension. When you get multivariable calculus, you will learn what is gradient and what is the function of gradient. Okay? But I will use, when we are I'm relating to potential energy, just one dimension. Or three dimension, but with respect to r. Okay, so this is for future. But this is important, which we have here. These are two formulas very important in the concept. So now we know what is a potential energy. Let's give an example. If I give the force as a function of x, 3x squared minus 3, x plus 2. That is the force. Let's say that that force is conservative. Depends on the final and initial position, not on the path taken. You can see that this, if I find the work, if I want to find not the work, if I want to find the work, will be just the integral of that, according to this equation. If I want to find the work, will be that. If I want to find the change in potential energy, what will be? Let's say I want to find the change in potential energy from 0 to 50. What do I do? This is the conservative force. According to my definition, if I have the conservative force, how do I find the change in potential energy? Negative. Don't forget the negative. The integral of 3x squared minus 3x plus 2 dx. What will be delta u? Negative 3x cubed over 3 plus 3 squared over 2 plus 2x plus c, but because it's from 0 to 50, I just need to get the c with a definite integral from 0 to 50. And I apply the second fundamental theorem of calculus. Any question finding if I give the conservative force the change in potential energy?
Wouldn't it be minus 2x?
Yes. Yes. Minus because it's negative. Thank you. This will be a typical question if I give the potential energy, or if I give the force, find the potential energy. The reverse will be if I give the potential energy, let's say, given by this function, 1 over 1 or r over 1 plus r squared. This is my potential energy. Now, yes, let's complicate it. Let's say, again, if I give f as a function of r over 1 plus r squared, dr, and I ask, find the, and that's a conservative force, let's say, find the change in potential energy. What do? We integrate. Again, delta u is negative, the integral of r over 1 plus r squared dr. How do you solve this integral? U substitution. Everybody can see that this is a U substitution, right? Since it's a U substitution, you can use either substitution or parent recognition. Parent recognition, you just put this as r squared and you add 1 and you know that it's a lane. Let me just do U substitution, which is what you are used to. 1 plus r squared du to r dr. So du over 2 equal to r dr. Now I substitute. My du will be equal to negative. R dr is du, the integral of du, divided by u, which is divided by 2, 1/2. So this will be negative 1/2 ln of u, which is 1 plus u r squared plus c. Is that correct?
You don't put the absolute value.
No, because this is an even function.